start. Okay, good morning, everyone. It's morning here in Botswana. I'm going to be making my presentation. The title of our paper is Business Intelligence and Data Warehouse Technologies for Traffic Accident Data Analysis in Traffic Accidents Data Analysis in Botswana. So, my name is Monkgogi Mudongo. I'm a lecturer in the University of Botswana. I've written this paper with colleagues, and I'll just start straight away with the introduction or with the background. So road traffic accidents are a serious problem here in our country, in Botswana. They are the major causes of deaths in Botswana. They are actually the second largest after HIV and AIDS. Of course, these days we have COVID. I think COVID is the #1 killer. So which means it will be the third after COVID and HIV and AIDS. So as a result of these accidents, a large amount of money is used to compensate those who are affected by road accidents. So we have an organization which is referred to as Motor Vehicle Accident Fund. So it is responsible for compensating those who are affected by these accidents through medical expenses and rehabilitation, through funeral expenses, through loss of support to those who have been affected by this road accident. So as a result, a lot of money is used in this accident, and developments end up suffering because the money will then also be channeled to compensate, not only to compensate, but also to deal with this problem. So it is important for relevant organizations to have a reliable source of data for accurate evaluation of traffic accidents. We believe that for decision makers to make informed and quality decisions, they need a reliable source of data. They need a system, a reliable system that can provide them with the right information at the right time in order to make quality or informed decisions. So it is important for these organizations, like I said, to have tools and technologies that will help them transform data into valuable information that would assist in comprehensive managerial decision making. So traffic departments in Botswana are not exempt to ever increasing data. They are also experiencing increasing data because they capture these accidents as they happen on daily basis. They capture them in their database. So as they capture this data, it means the data also increase in volume. It becomes immense, and it becomes overwhelming. So as a result, these organizations also need some mechanism or need some tools and technologies that they will be used to make, that they can use to make use of this ever increasing data. So here in Botswana, we have many departments that deal with traffic management. But for our solution, we have decided to demonstrate the possibility of our system using only 2 organizations, even though there are other 2 that we did not include here in our solution. So the 2 departments that we are going to be, or where we got data from, will be the Botswana Police, which is responsible for capturing the accidents as they happen, and also the Department of Road Transport and Safety. This one is responsible for registering new vehicles and also issuing driver's licenses. So there are 2 strategic areas of interest that we are going to be looking at, or that we looked at in our paper. So here we're looking at the traffic accident analysis as well as the vehicle registration analysis. So the traffic accident analysis, in this area, we wanted to investigate the traffic accident in relation to location, casualties, driver's details, vehicle details, and road details. Here we're looking at all these elements to see how accidents are affected by these locations, or where do accidents happen, as well as how they are influenced by these factors that I mentioned above. So the following are sample strategic questions that we'll address with our solution. Remember, I said we are creating a solution that is aimed at helping decision makers to make informed decisions. So the strategic decision makers may want to know what is happening in the country regarding accidents, and they may have questions that they want to answer through the data that is available, or they may have questions that they want answers to through the available data as is captured on daily basis. So these are some of the sample strategic questions that may be addressed through or that may be answered through the data that we were provided with. So the strategic decision makers may want to know the number of accidents that have been registered across the years as classified by accident severity and the year in which the accident happened. Then they may also want to know who are involved in these accidents. That is the classification of the accident victims by gender, by class, as well as by age. Then they may also want to know, where do most accidents happen? Do they happen in urban areas, or do they happen in rural areas? Do they happen in towns, or they happen in villages? Do they happen in cities, or they happen in wherever? So this question can also, we are going to attempt to try and use our system to respond to this question. So also, they may want to know, when do these accidents happen? So here we are looking at the time and the day of the week. What time do most accidents happen? And where do which day do most accidents happen? So we may also want to know the status of the roads. Where do these accidents happen? In which kind of roads do they happen? What would be the status of the road? Was it slippery? Was it a rainy? Were there road markings in the road? And was it a tarred road, or was it a gravel? So we are going to also try to attempt to answer these questions through our system. So another strategic area, like I said, we also wanted to investigate the vehicle registration. So this strategic area provides an investigation into the vehicle registration to try and understand the vehicle registration, the kind of vehicles that are registered as classified by the model or the make that is registered, the year of registration of that particular vehicle, as well as the vehicle location. Of course, there are many other important elements that are available in the registration data. So like in the previous area, here also there are specific questions that managerial decision makers may be interested in. For example, how many vehicles were registered in the past 5 years? Where are the most vehicles registered? How many vehicles are currently active on the roads? Or which vehicle model is mostly registered? Of course, these are only sample questions. Remember, the moment you have a business intelligence platform, you can ask any question that you want. You may change how you want to ask your questions. You may even generate new questions. So these are just sample questions to try and demonstrate our solutions. But of course, managers can answer any question or can query the data warehouse to extract any question that they may be interested in. So let's try and look at related works. Let's try and look at how other people approached this traffic accident analysis in other parts of the world. So business intelligence, or BI, is simply a combination of various components and tools, and these tools work together collectively to transform operational data into quality information that can be used for decision making. So it is the process of taking large amounts of data or big data, analyzing the data, and presenting a high-level set of reports of business actions to enable management to make fundamental daily business decisions. So this is from reference number 7, which is also available in our paper. If you want to see the details of this, you can visit our paper, and you can read a detailed literature review on this. So what I'm trying to say here is BI is about taking a large amount of data, then analyzing this data using different tools and technologies in order to bring, to generate reports and information to the decision makers. So the objective of BI is to improve the timeliness as well as the quality of information. You'll understand what I'm referring to by the quality when we talk about how data is extracted and how it's transformed to make it quality data. So this is to enable managers to be able to make better, or to better understand the position of the organization, and to be able to compare their organizations with their competitors. So remember, this BI technologies can not only be applied to traffic, but they can be applied to different other areas. So Ralph Kimball defines a data warehouse. A data warehouse is a very important component of business intelligence. So Ralph Kimball defines a data warehouse as a source of data in the enterprise that extracts, cleans, conforms, and delivers source data into a dimensional data store, and then support and implements the querying and analysis for the purpose of decision making. So a data warehouse is an integrated platform that extracts data from different sources in the organization, bring this data together for the purpose of easy access to the data, as well as easy retrieval of information from the consolidated repository. So BI components and tools include the data warehouse, like I said. It includes the ETL process. We'll talk about it in the upcoming slide. Then also the online analytic processing, data mining, text mining, web mining, data visualization, geographic information systems, and web portals. All these are the components of BI. They can be brought together in order to come up with a very powerful platform that can be used for decision making. So a BI solution. So here in this slide, I'm trying to take you to other parts of the world to see where the BI solutions were applied in different situations in relation to traffic accident analysis and evaluation. So the first example that we are looking at is a BI solution that was proposed in a study in Serbia. So in this solution, so the accident data was extracted from operational databases to establish the possibility of using those databases as the sources of data that are required for road traffic analysis. So the data sources for this solution in Serbia were the data from the Ministry of Interior, from the health authorities, from the insurance companies, from the road directorate, from the statistical office, and from the results of the researches that were done on traffic accident. As you can see from this example, the data was pulled from different sources, from different ministries, from different departments. That's the whole purpose of business intelligence. bringing data from different locations, integrating this data, bringing it into one location so that they can be easy access or they can be easy information retrieval. So another solution was demonstrated by a study that was conducted in Victoria. They also tried this BI technologies through an SAS enterprise-based data warehouse. And their data warehouse was called Statistical Application for Population Health and Intelligence, or SAPARI as the abbreviation there. Then from this data warehouse, or from their data warehouse, they were able to do annual trends graphs. They investigate the annual numbers and incident rates. They were able to be easily accessed from their data warehouse. So the data sources for this solution were data from the road safety agencies, from hospitals, and from emergency departments. As you can see, they are still also extracting data from different departments. So now let's then go to our proposed solution here in Botswana. Let's look at the data sources that we used for our solution. So here, the data for traffic accident is kept in transactional information systems for different departments, which means different departments have their different systems that capture accidents. If it's the Department of Transport and Road Safety, they capture the registration in their system. Then the Botswana Police will also have their system, which they will then use to capture the accidents as they happen. So the files that we used were from the traffic accident database from the Botswana Police and from the vehicle registration system from DRTS, which is a department that is responsible for vehicle registration. Now, the traffic accident database, from there we got three important files. The first one is the attendant circumstances, which captures the accident as they happen. They capture the date of the accident, the time of the accident, the type of the accident, and many other attributes regarding the accident. Then they also capture the causality details. Here they capture things such as the age of the victim of the accident, their class, whether they were a driver or a pedestrian. Basically, they capture the details about those who were involved in the accident. Then they also have the vehicle details. Here, this is the vehicle details of that particular vehicle that was involved in the accident, the model of that vehicle, the make, and many other attributes that are associated with the vehicle. So we also have the vehicle registration file, which was provided as an Excel file with attributes that are captured when a vehicle is registered. So all those attributes were available in that file, and it's one of the files that is going to be extracted and loaded in our system. So the accident data, which we got from the Botswana Police, comprised data from 2012 to 2020. As you can see, the big data, the data warehouse is a very powerful tool which can analyze both historical and current data. So that's one thing that makes it different from just a normal database, is this ability to be able to analyze or to be able to extract data as far as 10 years, as far back as 20 years. So you can see that the issues of scalability are very important when it comes to data analysis using the data warehouse. Then also the data vehicle registration data, we extracted all the data that was captured from 2015 to 2020. Now, what is the methodology that we used for developing our BI platform? So we used the data warehouse development methodology, and this methodology is the Ralph Kimball methodology, or the dimensional modeling methodology, as is popularly known as. So as per this methodology, emphasizing on building the data marts first to provide the reporting and analytic capabilities for specific business or functional processes. We look at certain dimensions, and then later, these data marts are then brought together to create a comprehensive enterprise data warehouse. In dimensional modeling, you start by identifying dimensions. These are the dimensions that you are going to use or that are going to be populated with the data. So you look at areas of interest, then you build your dimensions looking at those areas. So the dimensions are developed around the identified strategic questions. Now, and also, we're using SQL Server for developing our solution. So it was implemented in the SQL Server platform, which supports SQL Server integration services. It has the integration services, which brings data from brings together data from different locations. Then it also has the SQL Server analysis services, which is very critical when now it comes to analyzing your data. It also have SQL Server reporting services. Then we also used Power BI, which is a tool or a software which is used to create interactive data visualization and reports. This one is mainly used for data visualization and generating reports. So Microsoft Visual Studio was also used as part of the solution to build the packages and also to connect us for easy extraction of data packages. So these are the dimensions that were identified in the solution. We wanted to have a dimension that deals with accidents that will have this dimensional table here will have attributes that pertain to the accidents. You'll see the star schema in the next slide. Then we also have the causality dimension. We have the vehicle dimension, the road dimension, the driver dimension, which captures details about the drivers, and then the location dimension. Then we have the vehicle registration dimension. Then we also have the time dimension. So we are going to represent these dimensions using a star schema. So the dimensional model can be represented with a star schema. Kimball and Ross, in their publication in 2012, they defined a star schema as the generic representation of a dimensional model in a relational database in which a fact table with a composite key is joined to a number of dimensional tables, each with a single primary key. Here, all those dimensions that you saw in the previous slide will then be joined to a table referred to as a fact table, then to try and bring this data together. So the star schema shows the dimensions and the attributes that are essential in answering the strategic questions. So this is a star schema. So as you can see, we have the accident dimension there. It has the accident key, which is of course the primary key, then the day of the week, the accident severity or the type of the accident, and also we capture the cause of the accident. Of course, because of space, there are also many other attributes that are available here. You can see those attributes in our paper, in the detailed paper. So then we also have the vehicle registration dimension. It also have the reg number as the primary key, then also other attributes that are going to be extracted from the files that we are provided with. Of course, there are many other dimensions here. Because of time, I will not be able to go through all of them and explain what the attributes that are there. But as you can go through, you can peruse through and see what are entailed in each dimension. But the table of interest is the fact table. So the fact table brings the keys from all these tables. It brings together all the keys from they become foreign keys when they are in the fact table here. So also, the fact table is very important because it's used for storing measures. If there are any calculations that you can make, you can have attributes and have those attributes available in the facts table. So let's look at this. Looking at the problems that we have discussed in the previous slides, of having the data dispersed and stored in different locations, we have concluded that a technological platform is needed that should support quality analysis of data by way of extracting useful information to support the decision making. So our research or our paper proposes a business intelligence through a data warehouse technology for the traffic accidents and vehicle registration data analysis. So maybe a recap, we said business intelligence is a collection of activities which help us to understand business situation by performing various types of analysis on the company data as well as on the external data. It does not only look at the data that is available within a company, but you can even go to the external data. Then this should support strategic, tactical, and operational business decisions. Then this provides, the BI platform provides an integrated and total view of the enterprise. So it makes the enterprise current and historical information easily available for decision making. So it employs dimensional modeling, like I said, where we'll have measures, facts, and dimensions. Then you can perform what we call the ETL process. You'll see it in the upcoming slide. Then the BI platform also facilitate the online analytical processing and of course, generation of different kind of reports. So this is our architectural blueprint. So this is the operational data. As you can see, we have vehicle registration data. We have the police data from the police database. And of course, like I said when I started, there are of course many other organizations in Botswana that capture data on accidents, like Statistics Botswana. But we have decided to, because we're only provided with the data for the two, we have decided to only demonstrate our solution using the first two. Then once the data is in the operational databases or files, then we can perform what you call the ETL process. The ETL process stands for extract, transform, and load. You'll see it in detail in the upcoming slide. So the data is then extracted from the source files into the data staging area. The data staging area is where I was just saying, for our solution, we thought it is very, very important to have the data loaded in the staging area first before it can go directly to the data warehouse. Because in the data staging area, this is where the data can be transformed. When we are happy with the transformation and with the quality of the data there, then we can then load it in there in the data warehouse. Okay, so this is a screenshot from when we were building our solution and when we were extracting data using SQL Server. So we had a source data file, the accident data file, with a whole lot of the data that was captured on accidents from many years. So the data file is extracted, or the data source will be extracted, and then it goes through the data transformation. Now, at the data transformation here, this is where the missing values are replaced. This is where the data types are converted so that they conform to what we want in the data warehouse. This is where we merge different files if we think they must be loaded in one dimension. This is where we do all sorts of data transformations. We can aggregate, we sort the data so that when it goes to the data warehouse, now it is quality data that will give us the correct and quality information. Like I said, we thought in our solution we should extract the data, then transform it, then load it first in the data staging area or in the data staging database. Then once we are happy with the transformation, then we can start loading the dimensions. Now we are loading the dimensions from the data staging area. We are not extracting into the dimensions from the Excel files that we got there. We load them first in the data staging area. Then once the data is in the staging area, then we can load it in different dimensions. As you can see, this is a process. We are demonstrating a process of loading 2 dimensions. For example, here we want to load the road dimension. Then we are going to go to the table that is in the data staging area. Then from there, pull data from that particular table. Then, because we are going to be automatically generating IDs in the dimensions, or in the dimensions there, it is important that we must always update or auto-generate the unique identifiers or the primary keys in the data staging area. Then once you have pulled that, then you can load the data in the dim location or in the location dimension, or as well as in the road dimensions. So we are simply pulling from the staging area into the data warehouse. Okay, now once the data has been loaded in the data warehouse, sorry about that. Once the data has been loaded in different dimensions, then we have integrated data. Then we can query from different dimensions. We can pull different attributes and mix them from different locations, depending on the question that we want to answer. So we are going to try and attempt to answer the questions from our previous slides. So let's look at the traffic accident results. Now that we have demonstrated that we have pulled data and then loaded into data warehouse, then we can answer any question that we want. So the traffic accident results here, the first strategic questions that we may want to answer is, how many accidents have been registered across the years as classified by severity and year? As you can see here, we have different years from 2012 to 2020. Then at the top here, there we have different types of accidents or accidents as classified by severity. We can have the damage only, where it is only the damage to property. There is no damage to, or there is no death or any other injuries to people. We refer to that as damage only. Then we have fatal accidents. These ones are the ones that leads to death. Then we have minor accidents, and we have where there are minor injuries. And we have serious accidents where we have serious injuries incurred by the victims. So the demonstration here shows that, or the results shows that most accidents that happen are the damage only. There are a lot of accidents, but most of them only result as a damage only. Then we have fatal accidents where people die in those kind of accidents. As we can see, in all these years, we have lost 2,985 citizens, which is quite a very big number for us, because here in Botswana, we are a small population. We are only 2 million. So this number to us, if this number of people die to us, we have lost a whole lot of people. Then, of course, after damage only, then the next is minor injuries, then serious injuries, as well as fatal accidents. Then the next strategic question will be, how many accidents have been registered across the years as classified by severity? So basically, no, this is basically an explanation of the previous slide. So as you can see, we have explained that damage only accidents have the most interesting recent trends. Now from this year, from the years, you can actually realize that there have been a 11.93 decrease in the last 3 years on record. Then the number of damage only, they've also dropped from 13,491 to 11,881 between 2018 and 2020. For the previous years, we have been having an increase in all these accidents. Then for minor accidents, they have experienced the longest period of growth between 2012 and 2020. Now, the other question that we may want to answer is how many accidents are recorded in each police district as classified by years. These are police districts in Botswana. So here we are simply trying to investigate the number of accidents that were recorded in 2015 in a particular police district. So the results indicate that the Broadhurst police district, which is in the main city, in the capital city of Botswana, there it recorded the highest number of accidents, which is 27,778, followed by G West, which is also in the capital city. You can see that from these results, we have many accidents in the capital city. So the lowest number of accidents were recorded in Tabong. Tabong is a village outside the city. It's actually a rural area. So you can see that from this, we can conclude that a lot of accidents happen in the cities as compared to, or were recorded in the police districts that are in the cities as compared to those that are in rural areas. So then another strategic question is, when do these accidents happen as classified by the time and day of the week? So this graph simply shows that a number of accidents happen on a Sunday, which is a weekend. Then they also happen on a Sunday. You can see that when we go towards the accident, towards the weekend here in Botswana, our accidents will be increasing rapidly, So a lot of accidents happen over the weekend. As you can see, Saturday and Sunday has the highest number of accidents. Of course, Monday also, because we'll be from the weekend, probably, we also experience a number of accidents. So also, we may also want to know who are involved in this accident as classified by age and accident severity. So as you can see from the grand total there, the most affected group is the age group of 21 to 40. Those who are aged 21 to 40, they are the mostly affected by accidents, followed by those who are 41 to 60. These are probably those who are in their active years, and we have seen the numbers growing rapidly over different kind of accidents there. As you can see, we still have those severity or those types of accidents also appearing there to classify which accident group is associated with which particular type of accident. So Power BI allows us to create interactive dashboards to be able to do data visualization. That is to say, have just one interface where decision makers can straight away go to that and be able to see, okay, which police district is mostly affected. At the same time, still in the same screen, they can see where do most accidents happen. As you can see, this pie chart here indicates the type of accidents by location. Then this one here shows the type of accidents by year and also by type of accidents that has been happening. As you can also see, you can see the number of accidents by day of the week, as well as the numbers that happen during those weeks. So Power BI can create this very interactive and these wonderful dashboards where we can simply go through and see the number of accidents and within twinkling of an eye. So then the last part of our results will be the vehicle registration. Here we wanted to know how many vehicles were registered in the past 5 years. Then the number of vehicles registration shows a drop from 65,535 to 24,457 between 2019 and 2021. So vehicle registration also experienced the longest period of growth between 2015, which means in 2015 and 2018, we registered a high, the longest period of growth of vehicle, or we registered more accidents between these years. So 65,535 in 2019 was the highest number we've ever registered. And then which contributed to 57% higher than 2021 in 2020, which had the lowest number of 41,741. Probably the number has gone down because it's COVID. So we were experiencing a lot of lockdowns and there wasn't much activity. So also another question, we also wanted to see the number of vehicles that are still running, that are still in the roads, that are still active. So an evaluation of the vehicle status indicates that all the vehicles, that indicates that of all the vehicles that are registered, 327,026 are currently active, which means we have this number of vehicles currently active. Then 9,666 vehicles were exported, meaning they have been taken to other countries. And then RAN refers to the active accidents, as you can see from the pie chart, 327,026, which is 97%. Then the results also reveal that 142 vehicles have been scrapped, which means they are no longer active, they are no longer available in our roads. So now in conclusion, we can conclude that the development of this BI platform for traffic accidents is a very important contribution to research, and also a very important contribution to this country. And it has proven to have an immense impact on information delivery for accident data analysis and for vehicle registration, as demonstrated by our results. So through this platform, quality decision-making can be achieved when decision makers have information, the right information, in the right format, in the right quality, and provided at the right time. Then through data visualization, the injury prevention departments can view the statistics on different categories and can query the data warehouse to get answers to any questions that they have. So data is made easily accessible to decision makers, which they can use to come up with accident prevention strategies, and also to come up with traffic safety improvement measures. If indeed the results show that we have many vehicles in the roads, because this can also be classified according to cities. If the results show that we have many vehicles in Gaborone, then the decision makers can come up with a decision to say maybe we need to expand our roads, or maybe we need to have more traffic cops in the road to control the traffic, or maybe we can have, they can buy or they can ask computer scientists to come up with technologies that can monitor traffic and many others. Only this can be made available if they have informed, or if they have information that will help them make informed decisions. So also, the vehicle registration data marks can also help in the answering of questions pertaining to vehicle registration. So this information will inform managerial decision makers about the number of vehicles that are active in our roads, and also about any finer details about vehicles and about many other important issues. So thank you very much, guys. That will be all from me. I don't know if you have any questions. I will hand over to